Hi, everybody. Here's the three theorems from section 3.4. So hope you've read the two definitions that I had for you. Oops, there's a bell. Sorry about that. I'll just wait for a sec. First one, 3-4-1 says if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Now, please notice right underneath it in parentheses there, it says two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. That notation right there at the bottom of that is one that you're going to start seeing more and more. We ran into it once earlier and haven't seen it in a while. You're going to see it more and more. Try and start using it. So take a look at the picture underneath the hypothesis. Okay, we know this, that those are a linear pair. Okay, and if the linear pairs are congruent, linear pair means that they are supplementary. So that means that it would have to add up to 180. Well, if they're the same and they're supplementary, they both have to be 90. And our definition of perpendicular lines are lines that form right angles, which are angles that measure 90. So therefore, they make that conclusion L is perpendicular to M. Okay, look at 3-4-2. Underneath that, it's called the perpendicular transversal theorem. It has a name, okay? And when they have a name like vertical angle theorem or linear pair theorem, you need to know that that's probably something that's pretty important, something that's probably quizzed or tested upon. Okay, it says in a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line as well. So take a look at our picture in the middle. You see that box up there? Okay, so it has a box, which means that it forms a right angle. Those lines are perpendicular. If you go down to where line Q crosses P on the inside of those two parallel lines, aren't those two corresponding angles? And so you could actually prove this one by saying because the corresponding angles are congruent, they both measure 90 degrees, then it has to be true that if a transversal is perpendicular to one of two parallel lines, it has to be perpendicular to the other one as well. Okay, so corresponding angles could be used as well as some of those other theorems or postulates to prove that 3-4-2 is true. Okay, look at 3-4-3. If two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other, and then they have that notation down below at the bottom of that one. You know what the relationship is between 3-4-3 and 3-4-2, the second and the third one? They are called the converses of each other. Okay, and so the hypothesis and the conclusions are flipped. Notice with theorem number 2, we're trying to show that the lines are perpendicular, given that the lines are parallel. And in 3-4-3, we're trying to show that the lines are parallel, given that the lines are perpendicular, or the transversal is perpendicular. So it's a converse, which means flipping around the hypothesis and the conclusion. All right, thank you.